Hi, this is FIFO, and today we're starting a new series to talk about a classic wrapper. This is an approach aiming at extending the capabilities of Stellar native assets into something more granular and more personalized. In this series, we're going to go through the use cases, the applications, we'll walk through interactive demos that you can play with, and also show the code base in the end and do an exercise together. So stay tuned and let's do this. Before we start, what are we trying to achieve with this classic wrapper? So the idea here in this series is to have a thought exercise together. We are going through this approach and how it can be used in real use cases, but also we are going to think in a way of standardizing this so that other builders in the ecosystem could leverage these standards to easily integrate very customized assets into their wallets and applications. So let's start with the use case. What are we trying to achieve here? First, in Stellar, we can think of two distinct ways of building assets. On the left, we can think about Stellar Classic, so assets that are native, use transactions that don't require smart contracts, and these have pretty clear characteristics. Generally, the transactions are very cheap. You pay a fraction of a penny to run hundreds of transactions. You can fit up to 1,000 native operations in one block, so under 5 seconds. You have a higher throughput because of that. You have a standardized behavior, so you know that every asset built with native capabilities are assets that behave in a predictable way, that behave in a standardized implementation. And even with that approach, they are very fairly customizable. You can combine different control flags to achieve different outcomes for your asset. So in the end, you can come to the conclusion that they are very low effort in terms of implementation. You can easily run a bunch of transactions and have your asset up and running in a customized way. If you look at the other side, we have Soroban, the smart contract layer that came earlier this year. So with Soroban, now you can have fully customizable assets. You can build an asset from scratch with your own implementation, and that means you can really go crazy in what sort of personalization you're bringing into the table. Your asset can have very unique characteristics. As a consequence, this means that the cost to run these transactions are going to depend on the complexity and the amount of resources you're using, but at the same time, you also have direct access to other contracts and other DeFi applications, so you can easily integrate with other contracts through their interfaces and functions. So generally, whenever someone is thinking about building an asset Stellar, they think about these two ways. You can either have a classic asset, which is a bit less customizable, but very scalable and cheap and easy to integrate. And on the other side, you have pure smart contract tokens that can achieve very unique behaviors, but at the same time require more effort and also require a more conscious approach about how you're building it and integrating in terms of costs and resources. So there's not just these two ways. There's actually an additional way, which I think is the actual big differentiator for Stellar. So if we move forward, there's this third way, which is the SAC. So every classic asset in Stellar can be deployed into a smart contract called SAC, the Stellar Asset Contract. The SAC is a default implementation that comes natively with the platform and can be deployed once for each classic asset. It enables a smart contract interface for the asset that interoperates with the classic side of Stellar. Whenever an asset is used through the SAC obeys the base rules of classic. So this is a mean to provide an interface through smart contracts to access the classic capabilities. This is great because it allows for hybrid assets to exist in Stellar. And with hybrid access, users can choose to interact through classic or through the SAC contracts. And in return, whenever they access through the SAC contract, they have access to other contracts and other applications because this contract lives in the smart contract layer and can interoperate with other contracts. So you can access all of those DeFi applications and use cases that are more robust and personalized. And in return, you'll be paying more in terms of fees. These will be a little bit more complex to integrate. On the other side, if all we want to do is to run payments, use the native DEX, and things that are more common, you can just use the classic asset, the native asset, and interact with those with very cheap and scalable transactions. I would really expect in the future to see a lot of assets being built in this way, allowing the users and the application builders to decide how they want to incorporate the asset in their use cases and how they want to provide this experience to the end users. But this doesn't cover all of the use cases an asset builder could look for or an application. So let's say you really want to look for a very customized behavior for your asset, a more granular way of controlling who's accessing it and how they're accessing, or even to just extend further the capabilities of the asset. This means you need to take extra steps and additional routes to make that possible, to provide additional customization. So what we're trying to bring with this approach is a way of providing this customization in a standardized way so that other builders in the ecosystem could easily identify and integrate this use case in their applications, as well as share implementations across the ecosystem so other builders could benefit from it. So if you saw the other series on regulated assets, this is kind of a step further after that. In that use case, we covered a way of achieving this kind of customization with just the right side of it, with just pure smart contract tokens. Now we're trying to bring an approach that allows for classic assets to benefit from this kind of customizations. And this is sort of an evolution for the standard defined in SAP 8. So if you don't know SAP 8, you could pause right now, have a look at it, have a look at the other series. But what is important to know is that SAP 8 is an approach to allow for classic assets to have very customized behaviors, but this depends on external services that are going to run off-chain to ensure transactions are executed in the way the asset issuers would like to. So this ends up centralizing the implementation and adding a weak point. So in case the service is offline, no one is going to be able to use the asset. So what we're trying to do here is to bring all of this responsibility to the on-chain side so it can run alongside the infrastructure of the network. So, all right, people, how are we trying to achieve this and what is the proposed approach? So what are we trying to achieve here? At the bottom line, there are two approaches that we're proposing with the classic wrapper. One that is very tight and aiming at asset issuers that want to enforce a specific behavior, and another one that is more flexible, that is not exclusive to asset issuers. It could be applied by any builder in the ecosystem in case they want to provide a different route with specific behavior. So if you want to have a different way of interacting with the assets that is optional and allow you to interact with other behaviors, that would be the second approach. So in the first one, let's cover the enforced approach. In the forced approach, we want to make sure that users cannot access the classic asset through the native token, neither through the SAC contract. We are going to make sure that these users won't be able to run transactions invoking those directly. If they want to interact with this asset, they need to do this through a special contract called the wrapper. The wrapper is this one with the green token on the right side. And the idea is that this contract is the only entry point to the asset. So whenever someone invokes the wrapper contract to make a transfer, the wrapper contract will call a second contract, which is called the asset controller. So it's a special contract that contains all of those custom behaviors. And this contract will decide if the transaction should or shouldn't go through. So if this contract allows the transaction to go through, then the wrapper contract will trigger the SAC and consequently update the status of the asset. So how does that work and why are we adding two separate contracts? Well, the idea here is to separate responsibility. We can have a wrapper that is a very standard and very common implementation to be shared across different applications, and we separate the personalized and the custom logic in a specific contract. So that one can be very unique to each use case and also provides an easy maintainability. So if you want to switch the way the rules work in the future, or you want to implement new rules, you can simply switch this asset controller contract to a new one and keep updating your asset's behavior. And also if you want to flexibilize the behavior that once were more strict, you can also do that by just playing around with this contract. So the idea here is we're going to build a wrapper contract that is going to access an asset controller token to verify unique rules, unique behavior. If anything happens that would make this transaction invalid according to the rules of the issuer, this contract will just invalidate the transaction and it won't go through. But now, if everything is okay according to the rules, the wrapper will simply redirect these to the other contracts and it will go through. All right, but how are we achieving this? How are we making sure that users cannot access the other interfaces to interact with the token? And how are we bundling together this use case? So to start off, something we need to do in the classic asset is to enable two flags, the auth required and the auth revocable. With these two flags, we are making sure that first, every trust line, every account that wants to interact with this token, they are only able to transact and use the token if the trust line is authorized by the asset issuer. So that means that if I go there right now and create a trust line for this asset, I won't be able to transact or hold balance unless the admin and the asset issuer tells me that I can. The second one, the auth revocable, it defines that the issuer can at any moment revoke the approval of an account. This is normally used to apply freezes to accounts or install KYC processes to make sure that only accounts that have gone through KYC are approved and can operate with the asset. So in this use case, we are making that to ensure that anyone that wants to interact with the token won't be able by default to interact through Classic, neither SAC. They're going to need an authorization. And we are going to manage this authorization in a programmatic way. So the second step is that we set in the wrapper contract, the SAC contract, the Stellar Asset Contract, which is the default implementation, we define that the admin is not the asset issuer anymore. We define that admin is our wrapper contract. This means that logic runnings on the wrapper contract can invoke admin functionality in here, and we make those functionalities available to the original issuer, or let's say a consortium of asset controllers, through the wrapper. So whoever has the rights in the wrapper to run the admin functions will trigger those through this contract. And the idea of doing that is to keep a programmatic way of approving and revoking authorization of these accounts. Now, in the wrapper, what else do we need to do? First, we need to ensure that whenever someone wants to run a transaction, these transactions are going to pass through the custom behaviors. And the custom behaviors could be just rules that are being enforced, or simply additional behavior to apply a marketing campaign or gamification or something like that. So the wrapper has to make sure that whenever a transfer or any other transaction that is being executed by the end user is being triggered, it is also going to trigger the asset controller. The asset controller will verify and apply its rules, and if for some reason it decides that the transaction should not go through, it needs to panic and throw an error, and that will make sure that all transactions that don't abide by the rules are going to be invalidated right away. If everything goes well, it applies its logic. If you have to keep track of states or anything, it's going to do on itself, and then it passes on the baton back to the wrapper, and the wrapper will be able to proceed to run the transaction. And in order to run the transaction, it basically runs 3 steps. First step is it momentarily approves the accounts, telling that the accounts are able to interact with the SAC. Then they already execute the transaction, and once the transaction is executed, they revoke the authorization for that account. So that means that in one go, it's going to authorize the accounts, run the transaction, and revoke the authorization. So that ensures that everything runs in an atomic manner, and the users can only run these transactions through the wrapper. And if you want to extend this further, you could at a certain point, programmatically or manually, approve a trust line, making so that the accounts don't need to go through the wrapper anymore. They could simply start leveraging the SAC or the Classic as normal. So you could create a very customized use case in which, let's say that prior to KYC, you apply certain limits to accounts and transactions and how they operate. But once they have done the KYC, you can simply release full access to the token in any way they would like to. So they could really leverage all of those good characteristics from Classic and the SAC. So that's the kind of stuff you would build with this use case. And how this would look, Here we have a thought exercise on example interface. It doesn't mean that every wrapper should have these functions, but we can think of standard ways of creating this implementation and make sure that builders are benefiting through the same steps. So we could say that for an enforced wrapper, we could have specific functions for the admins to activate and deactivate the wrapper. These could be used by the admins to make the wrapper active by turning them into the admin of the SAC. So they would pass on the baton of the administration of the SAC to the wrapper contract. And whenever they want to deactivate the wrapper, they can simply run the deactivate wrapper function, and then they would get back the admin role with the SAC. And they could switch to different wrappers and different implementations if they would like, or if they just want to retire the wrapper and go back to operating normally. Most importantly, the wrapper must provide or expose the functionalities they expect people to use from the asset. So if we want people to use the transfer functionality from our asset, we are going to expose these as the wrapper. And this is the functionality that the users will be triggering, and these are the functionalities that are going to be reviewed by the asset controller. And furthermore, we can think about standard functions that would provide information about this contract and how it operates or the current state, so that the application builders would benefit by knowing how it is going on and what they can do with the contract. One example is we could settle on a standard metadata for the contract. Several standards in the Ethereum ecosystem, for example, do approaches like this. They encode some information in the contract itself, so whenever someone is building a wallet or integrating with an asset like this, they can query this information from the contract and understand what kind of contract this is. So we could provide this to demonstrate to the applications what kind of wrapper this is. Is this an enforced wrapper? So everyone that wants to interact with this asset must go through it? Or is it an optional wrapper that can be used by the ones who choose to go with the extended behavior? Is this wrapper active? Who's this admin? Who's the asset it's wrapping in? Where are the rules? So this way you can provide upfront information about how your use case was implemented. So that's really nice, but it doesn't cover all use cases. You don't always need to enforce a rule. It's something you would expect if an asset issuer wants to, let's say, enforce a whitelist of applications that can be used. So let's say you're a central bank running a CBDC in Stellar, and you want to make sure because of your tight regulation that people are only interacting with known applications and whitelisted applications. So you could use this to apply this whitelist. But now, if you're working on a more flexible approach, you don't need to be the asset issuer. So if you want to go with the optional approach, the difference here is that we wouldn't do that initial configuration. We would still keep the asset and the SAC accessible by anyone, and we would just build an optional wrapper that if someone wants to go through these behaviors, they would use the wrapper instead of the normal entry points. So what is the benefit of that? You can think of it as a way, for example, for wallets to implement marketing campaigns. Let's say you want to do a gamification implementation for an asset or multiple assets in your ecosystem. Let's say I am a wallet and I want to promote usage of USDC and EURC. So I would create a wrapper that whenever someone uses these assets in my wallet through the wrapper, they are going to be accumulating points, and these points at certain point will meet a threshold and give a cash back to them. So that's a good way of incentivizing accounts. Another way could be to maybe install some sort of game that runs alongside with the asset. So whenever you are using that asset, you are acquiring experience for your digital pet or something like that, or you could get unique NFTs. This would be a more flexible approach that allows to anyone, not just the asset issuer, to build custom behavior for existing classic assets and let the end user choose if they want to abide by that or not. Other things could be simply that wallet partners or application partners could agree on whitelists of known applications, or at least block lists for applications they know that are not trustworthy and they don't want their users to interact with. So they could have a consortium to manage together a block list of applications that are not trusted and make sure that their users are interacting with those assets through their wrapper and going through this block list to ensure they're not interacting with malicious activities or malicious applications. And if the user still wants to do that, they can do that through a separate application for a different wallet. They can just get their keys and interact directly with Classic or SAC. So in this second approach, we could go way simpler. We could have a similar interface. The only important piece is that we would also need to expose the end functions that the users are going to use to interact with the assets, so the transfer, for example, and we would need to provide some upfront information so applications know what this interface does and how it is customized. So in the end, you have two different approaches that are there to cover specific use cases or specific needs, and then they can be leveraged in very different ways. So, all right, that was a quick introduction. Now, I want to dive deeper into real use cases to show you some examples, some interactive examples you can play with. And in the next video, we'll tackle the enforced approach for a wrapper. So, see you in the next video.